Okay, so we've already done problem number 1. We've already looked at, for the people watching the video, we've already done problem number 1. We've already looked at that we have to do the top minus the bottom. Thinking about sort of a vertical segment, think about you standing in the area. Where's your head and where are your feet? The top function, the head, minus the bottom function, the one that's under your feet. And we're going to integrate it from left to right. It's basically taking sort of a line segment and integrating it through a region, and that's what gives you an area. In that particular problem, we had boundaries given to us, left and right, 0 and 1 for x. In this problem, we have natural boundaries. We're asked to find the area bounded by these two curves. It doesn't give any other indicators, so that's typically the clue that you know, okay, I'm probably going to see an intersection that's going to naturally create a left and a right boundary. Okay? Because these two functions cross, there is one section of it where I've got a consistent top minus bottom from a left point to a right point. Now we've got this graphed on our notes for us, so we can see the intersections pretty clearly with a nice scale that that's an x of 2, and this appears to be x equals 2, and this appears to be x of negative 3. But if we didn't, this is where Desmos is really superior to your handheld. It does it so much more nicely. If we type in one of the functions, I will scroll out, and I'm giving them names just to make it easier. Oops, let's go back to our homes. Okay, so there we go. So there's our Desmos picture. All we have to do is click on one of the functions and it automatically highlights important points. I love this. This is my favorite part of Desmos. You don't have to go looking for intercepts or intersections like you have to do on the graphing calculator. I mean, it's a web-based program, so of course it's more powerful. So you've got the negative 3 to 2. So if I hadn't given you the graph, if I just gave you these two functions, and let's say I gave you just random letters, okay, so you can't assume who's on the top or who's on the bottom. You would have to graph this, and through the color coding, you can very clearly see, okay, this is the region I want. This guy's the top guy. This guy's the bottom guy. And I've got those 2 points. So I'll be, actually, how should I write it? Let me type it. Let's do this. So under my functions, down to my calculus functions. There might be a shortcut to get to that. I'd have to look for it. I haven't investigated that very much. Negative 3 to 2 this time. And the way I labeled them, oops, I'm going to need my big parentheses. Big parentheses, and then little h of x is my top guy, minus little w of x is my bottom guy. It won't do anything without the dx. So 20.833333, or 125 over 6. Let's write that on here. So negative 3 to 2. 6 minus x third minus x. X. So area. That's it. 125 over 6. These are going to be positive. Okay. You're finding the signed areas. If we use positives or negatives, it would be because they represented certain things. If we're just strictly calculating this physical area, then everything counts as positive and it doesn't really matter if there's stuff under the x-axis and stuff. I mention that because if you happen to do the work and get a negative answer, chances are you've got something flipped around. You've got either your limits of integration flipped around, you've got top minus bottom flipped around, because these areas are not going to come out as negative values. All right, any questions on number 2? Okay, then why don't you go ahead and try 3 and 4 and 5. The grid is there if you want to sketch a graph for yourself based on what you see on Desmos or on the calculator, or you can just kind of work from Desmos. Like I said, this is from my AB notes, so we've done some sketching by hand before because we had to make sure we could do this without and with a calculator. You guys do not have to worry about doing this without a calculator, so feel free, ignore that if you like. Figure out using whatever tool you need to who's on top here, top minus bottom, and it looks like for 3 and 4, you're also going to need the intersections to get the left and the right. Number 5, little bit clearer. So you didn't even start with number 5. Number 5 is a little easier than 3 and 4. Okay. Y equals 0, that's easy. That's just the x-axis. So if I was going to graph, it's kind of what that one looks like. Okay, I'm going to stop this. Actually, I'm just going to pause it, and then we'll come back and look at these 3. Okay. All right, I'm going to work through these with you just to kind of show you the basics. I'll probably do some sketching on here just because it's easier, so we'll have it on our notes. Obviously, you can sketch everything with whatever technology you're choosing to use. Let's see, I think E over 2A. So yeah, that parabola is like over here. So 1, 1, 2, 3, 4. 2, 3. Oops. 1, 2, 1, 2, 3, 4. Yeah. 1, 2, 1, 2, 3, 4. Okay. Hi. Thank you. Okay. All right. So there's that. And 1, 2, 3, 4. 1, 2, 3, 4, 5. The line up 2 over 1 down 2 over 1. Okay. So this we definitely need the graph. Well, you don't need the graph to get the intersection. It's nice, intersections. I mean, it's nice, but you can also get the intersections by setting them equal to each other and solving. I mean, that's an algebra way to figure out where they intersect. The two x's subtract away, so this essentially becomes x squared minus 4 equals 0. And then solving that quadratic equation, the solutions are plus and minus 2, which is exactly where these two functions intersect. They intersect at -2 and they intersect at +2. No reason for us not to use the graph since we are making the graphs and we have the ability, but if we didn't and we had to do this ourselves without any technology help, we could still figure out, make sure our graphs are accurate in that they intersect at -2 to 2. So, area calculation. Integral from -2 to 2, the line is on top. So 2x minus 5, or 2x plus 5 minus x squared plus 2x plus 1 dx. And I'm pretty sure, there, done, okay. So -2 to 2. If you ever want to simplify the subtraction of the two functions before you calculate the integral, you can. So you can distribute this negative and combine like terms. Those are things that make it easier if you're integrating by hand. not so necessary if you're using the technology, but something you can do. Okay. If you, what did I do wrong here? Oh, that's a plus one. Okay, there we go. X plus 5, x squared plus 2x minus x squared minus x. No, why am I, what's wrong with this? Why is it doing that? Let me try it here. All right, let's go here. Let's get rid of these. All right. So nice thing is, if you do some of these on Desmos, you can kind of not cheat per se, but you can make sure you get things kind of in the right place. You can use this setup. You'd have to make sure that you're gonna line up with what's on the top and what's on the bottom. So 2x plus 5 is my top function, so that would have to go in for h of x, and x squared plus 2x plus 1, there we go. That's all wrong. But there's the region that we're talking about, just like our picture. And so 10 and 2/3, 10 and 6/7, 32 thirds. Those are our answers. 32 thirds or 2/3. I was doing it on the handheld. I was getting a negative. I'm not sure why I was getting a negative. I shouldn't get a negative, so that's how I knew something wasn't right about how I typed it in. And sometimes that's just, oh, because it's not a -5, it's a +5. And oftentimes it's just something dumb like that. There we go. There we go. Okay. So mistyping is a huge, that's going to be your big mistake. It's like, okay, I know what I'm supposed to do. I set it up perfectly, but if you type a minus instead of a +5, then it's going to throw your answer off. You should be getting positive answers. So that, in fact, can help you. All right, so number 4, I think we've got, if I remember, this is an upside down and a right side up parabola. So 0, 3, 1, 2, -1. Okay, so it builds 1, 2, 1, 2. Nope, up to 3. Try that again. Up to 3. There we go. Once you kind of figure out where that vertex is of your parabola, it's pretty easy to build your parabola around. And then this guy, I know he intersects, actually no, I can cheat a little bit on this guy. And his vertex, I don't know if you remember this, vertex is the opposite of b over 2a. Gives you the x value of the vertex for a parabola. So I know the vertex at this guy is at 1 and 1 is yeah, okay, there, and then that one and that one, and then over 2, down 4, over 2, down 4, get something like that. Okay, so Mr. Upside Down is on the top. So if we were going to, and my intersection points are 0, x equals 0, and x equals 3. So 0 to 3, and in this case, using the names of the functions, g of x minus f of x. And this, weirdly enough, comes out to be a really pretty whole number. Exactly 9. Top function minus bottom function. If you are not getting the numbers that I'm getting, that you should double check is, are you entering things right? Did you mistype a number? Do you have the right scenario? Do you have these numbers? You know, if you're just popping an error, are you remembering your DX? All of those things are little things you can do. When we're integrating like this and calculating an area, we can't do it over an asymptote. So this particular function has a vertical asymptote at x equals 0. We couldn't do an integral from -1 to 1. The interesting thing is if you actually ask the calculator to do that, the calculator kind of doesn't know sometimes that it's not supposed to do things. And so it might do it anyway and just kind of give you a weird answer. So let's see, if we did ask it to do that over x squared, throw another parenthesis in there. Oops. Oh, why do you hate me? Okay. Oh, it doesn't do it. Okay. Sometimes it will, sometimes it won't. It does different things. So this kind of integral, it will yell at you because you can't really calculate the integral across here because it does have that asymptote. So it's really kind of almost like an infinite area. But in this case, I've asked you just to do from 1 to 5. So from 1 out to 5, that's totally legit. And y equals 0, just the x-axis, you actually don't even have to write that. You can do 1 over x squared minus 0, or not, dx. The minus 0 isn't going to change anything. It's good to come sometimes write it, though, to remind yourself top minus bottom. And I think this one you get 0.8 or 4/5. Let's see. If second entry can reprint, that's a handy tool to have. So let's clear that. That's a 1. And that's a 5. Yeah, okay. Even though I don't have the minus 0 in here, it's fine. Okay. Okay, so a couple other variations that we're not going to get into, but I want to just make sure you're aware of them. It is possible to have functions where, you know, we kind of change positions. A good example of that would be like having a sine function and then having a cosine, part of a cosine function, and you might have the cosine more spread out, but something like this. And if I wanted to calculate this area and this area, if I wanted to calculate all the area from x equals 0 out to here, oops, change that, okay. And let's recolor this. If that's my f of x and this guy's my g of x, I can see in this one little section, the g function is above f, and then in this section, the f is above g. You would have to actually do this in 2 pieces. So whatever this would be, we'll call that a. You know, this is x equals 0. So if we went from 0 to a, we would have to do the g guy, he's on the top there, minus the f. And then we would add on, okay, from a out here to b. And this time it would be f minus g. Okay. So we can do multiple pieces, and we may have to switch and do in sections. That's how we could do that calculation. You can't do it in one integral if top minus bottom switches, if they switch behaviors. And, you know, that's going to happen on things like sine curves and stuff like that, stuff that oscillates. Another sort of variation on this is if you had stuff that literally weren't functions, like sideways parabolas. And let's say this was the thing I wanted to do the area of right here. Like this is one function, so, or not a function, that's one curve. Okay, and this is the other curve. You can see top minus bottom is a little weird in this case because top minus bottom over here works one way, top minus bottom over here works another way. So one option sometimes for that kind of scenario is instead of doing top minus bottom, we go this way and do the function that's on the right side minus the function that's on the left. Now, a couple things happen when we do that. First of all, they have to be written like that, as x equals functions of y. So that's dy. And these become y numbers. So we would go from this y number to this y number. So we would be kind of adding up, going like that. It's another variation. You can do them that's like that if you don't have a clear top minus bottom. If something's like this that curves around on itself, a right minus left might be a better plan. Okay. But there's a lot of little other things you have to do with that. You've got to make sure you have the function, the curve names written the right way, x equal instead of y equal, and y numbers here and here. All right. I don't have an assignment that you have to do. I know some of you might want to practice some of these. That's just kind of like who you are. So what I have done is I found where I had a scan of a textbook page. Let me find that, not there. Let's find that textbook page where there was a set of these problems. Let me pull this up in, the best place to pull this up is in second period. Hang on. Second period, where is my Schoology? Okay, so Schoology, I will copy this stuff over to fourth period for you guys. So, kind of making a 6B folder, kind of consider that what's what we're doing right now. And so these are 2 pages. What I was suggesting though are the problems that are on page 358. Here, some of these would be good as practice problems. So I'm gonna go ahead and make sure that there's a key available for page 358 for 16 through 30, the evens. That is 100% optional. That is optional practice. Okay? That is so you can check and see maybe just even a couple of those to make sure, like, okay, can I get the integral set up correctly? Can I identify top and bottom? Can I get the right minus left part? Find where those are. There we go. I picked that group because some of these, they have the left and the right stuff given, but others they don't. So I think, you know, a couple, 16 and 18, 2 different scenarios, one where you have the left and right boundaries given, one where you don't. Something with a little bit weirder functions like the roots, some e's, just to make sure you're comfortable putting those in your calculator. I don't know what the deal is on 30. I'd have to look at that. So that would be my suggestion. If you would like to practice this some more, we're going to do applications of this next time. We're going to talk about why you would care about this, what you would use it for, what's that area good for in multiple contexts. But if you want to make sure you can actually do the calculations, this is a good place to practice.